All right, welcome back. Mr. P helps with calculus. This is Unit 4, Day 3, and analyzing problems that are involving rates of change. And we start off with this activator. This happens to be the AP Board lesson that they have on their websites. Instantaneous rate of change, as I've mentioned in prior videos, that is the derivative of. So A happens to be velocity. The derivative of position is velocity. Number 2, possible units for acceleration. Acceleration, remember, has to be per units squared. So number 2 was F, meters per second, because remember, you're talking about the rate of change of the rate of change of position. So it's meters per second per second. So meters per second would be the rate of change, the velocity, and it's the rate of change of that rate of change. Number 3, units of instantaneous rate of change happen to be G. G happen to be gallons per hour. Yep, could be. Yep, velocity, just, meters per second, gallons per hour, that could be. Number 4, possible units for position. Remember, position's going to be like just meters or, matter of fact, that's what it is. Meters or inches or miles or something like that. It's not going to be changed over time. It's just position. Number 5, instantaneous rate of change of velocity. Instantaneous rate of change of velocity, instantaneous rate of change of velocity. I had to think about that for a second. The change of velocity would just be acceleration. So number 5, let's see. Yeah, B. Perfect. 6, possible units for velocity. Velocity could be like meters per second, something like that. Let's see. What do we have? 6 was E. Oh, that's exactly what it was. Number 7, units for instantaneous rate of change of R measured in gallons and hours. Okay, instantaneous rate of change of R of T. So that would just be gallons per hour. Gallons per hour. Oh, wait, R of T must have been the rate of... that must have been the velocity. Instantaneous rate of change, R of T, or R is measured in... Oh, R is measured in gallons per hour. Okay, I missed that. Sorry, I'm having a hard time seeing the bottom of my screen. RT is the rate, so therefore the rate of that rate is the acceleration. All right, instantaneous versus average rate of change. Now remember, we've talked about this in the last 2 videos. Instantaneous rate of change just means that it is at that instance, whereas average rate of change means you had a starting position, end position. You're just trying to find what the average rate was over that time. So you're not talking about a derivative. You're just finding using the slope formula. Over the time interval from 2 to 5, that's an average rate of change, what I just explained. After 3 seconds have elapsed, if you want to know how fast something's going after 3 seconds, you can't use the average rate of change formula. That would have to be the derivative formula, because you're trying to find at that specific instant. Number 3, at noon. Once again, same thing as this. You're talking about at that one instant. During the first 5 minutes, that's from 0 to 5. That's an average over that interval. That's the key here. If it's over an interval, you're talking about an average rate of change. Over a 12-hour period, perfect. At 7 hours, at that specific instance, that just makes sense. Complete the last column of the following table. It's already been done for us. It says correct units using the derivative of the function given in the first column. The first row is complete as an example. So the first row is C of T, where T is measured in hours, T is measured in dollars. C prime of T would just be dollars per hour, dollars per hour. This one's going to be centimeters squared per second. This one's going to be, it's not actually written there. So A of T is going to be centimeters squared per second. And this is going to be kilograms per cubic meter. And this is going to be miles per gallon per miles per hour. Okay, interesting. All right. So it's always going to be that dependent per that independent. Oh, there we go. Didn't realize I already had it on there. All right. Complete each of the following verbal descriptions by filling the blanks of the information as missing. Be sure to include appropriate units. The first one is completed as, V of T gives the volume of water in a tank in liters after T amount of minutes. So V of 3, that would be the velocity at time 3 equals 20. 20 is what happens to be measured in liters. So it means after 3 minutes, 20 liters, because it told us right here. That's time in minutes and liters. So this is time in minutes, and this happens to be liters. All right, so this is the rate of change. So at the instant, it's decreasing by 2 liters per minute. So at 3 minutes, it's decreasing by 2 liters per minute. Perfect. It's pretty much exactly what I just said a second ago. All right, once again, some more situational questions. Says, given the area of the surface of the oil slick in square kilometers in T hours, we're just filling in what the units mean. So what does A of 24 equals 17 mean? Once again, it tells us up here, it's T is the amount of hours. This is the amount of hours, and this happens to be kilometers squared, it looks like. Okay, so that makes this make a little bit more sense. A of 24 means after 24 hours, it's increasing by 20, oh no, it's the acceleration. The area of the oil slick is 17 kilometers squared. Okay, it's the area of the oil slick. I didn't read that at the beginning. A primify means that's basically how much it's increasing or decreasing. So in the sense that it's positive, that means this is basically like the velocity. This is how much the area is increasing. It's increasing by 4 kilometers per hour at 5 hours. So that's the time at which it's happening. Remember, that's T. T is the amount of time in hours. C of S given the cost. Okay, gives the cost of dollars of digging a hole. Okay. Cost in dollars of X feet deep. All right, so this is the amount of feet, and the answer will equal the amount of dollars. All right, so this is 20 feet deep, and it's going to cost $140. $140, dig a hole is 20 feet deep. Perfect. I would have said it the other way around, but that's the same thing. This is the rate of change that the feet is changing, and this is how much it costs. It means that the hole is 20 feet deep. The cost is increasing, so it's increasing by $5 per foot. That makes sense because we're talking about the derivative. We're talking about the instantaneous rate of change. So at 20 feet deep, it's getting $5 more expensive. It's increasing. A of T gives the acceleration in centimeters squared. Okay, centimeters per second squared after T amount of seconds. So this is our seconds, and our answer will be centimeters per second squared. Okay, so that kind of breaks it down a little bit. A of 2 just means after 2 seconds, it's decreasing by 6 centimeters per second squared. I actually don't really like the way it should say decreasing because it's negative. It's it's acceleration. Okay, so the acceleration is -6. So we actually don't know if it's slowing down or speeding up. We wouldn't know that unless we also knew the velocity, as we've talked about in prior videos. A prime of 7. Okay, so A prime 7 means that after 7 seconds, the acceleration is decreasing. Okay, that's like kind of like a third derivative of position if you think about it, because that's how much the acceleration is changing at that time. All right, I think, we got one more. This is 40 years later, so it means at year 1990. Okay, that's a little tricky, because let me just read it from the beginning. P of T gives the population in billions of people of the world after T years. So this is the amount of years since 1950. This is years since 1950, and this is the amount of billions of people. All right, so it looks like in 1990, there was about 5.3 billion people in the world. So this is the rate of change of P. Okay, so that means after 60 years, so I guess in the year 2010, this is how much the population is increasing. All right, that's pretty much exactly what I said. So make sure you're using the word increasing. It says increasing at that rate. If this was negative, you would say decreasing. Very important distinction. Don't write negative numbers in your contexts. R10. RT gives the rate. This is very important. It's the rate in pints per second. All right, so this is seconds, and this will equal pints. The oil is flowing into a tank after T amount of seconds. Okay, so this is after 10 seconds. It looks like it's increasing at a rate of 3 pints per second. And that's pretty much what I just said. All right, R prime of 6. That means how much the rate is changing. It's how much okay, so at 6 seconds, that's the time right there. At 6 seconds, it's decreasing in pints by this amount, by 0.2 per second per second. Remember, this is a rate of a rate. Very important. This is per second, per second. Does that say? Yeah, per second squared. Perfect. All right. Thanks again for watching, and I will see you on the next video.